Hi, so Jay and I are doing our project on my thesis, which is on the tau protein. It is found in the brain and is known to pathologically aggregate or polymerize into filaments that form neurofibrillary tangles in diseases such as Alzheimer's. On the top of this slide, you can see an image of what the tau protein looks like, and specifically what I'm interested in is looking at the projection domain. So the way that I study this projection domain is using a mutant known as R5L, which essentially just makes this region of the protein more negative. And I also use shortened proteins, which just have deletions in this projection domain region. So the way that I studied it was I made these proteins and then I induced them to do this pathological aggregation, and then I could image my fibrils using AFM. So here's my data, and the way that I analyzed it was I individually selected the fibers to find both the length of these fibers and to see the number of fibers per image. And I also found the total area of the surface covered by tau, so I could figure out the total amount of aggregation.
The two questions that we wanted to answer for this project was, one, in terms of fiber length, number of fibers, and the total amount of aggregation, was there any data points statistically significant in showing the difference between isoforms and the typing? And the second question was that literature suggests the isoform 1N forms 50% more fibers than isoform 2N, and we were wondering if that was true or not. For the first question, we used a Bayesian MLR model, while the second question, we used a Bayesian inference of proportion. And for the MLR model, we used JAX to fit the model. For the MLO parameters, we had tau isoforms as 0N, 1N, 2N, where 0N was the reference category, and we had those as nominal categorical variables, while we had wild types and mutants to be a binary categorical variable, where mutant was 1 and wild type was 0. Additionally, we added an interaction term between isoforms and types. And for priors, we use a weakly informative with normal, 0 in the small precision indicating uncertainty. And we had different priors for sigma across the different MLR models. And for diagnostics and analysis, we had a trace plot, ACF plots, Gilman-Rubin diagnostics, and posterior predictive checks and credible intervals as well. For the proportion parameters, we had mu as 0, sigma as 1, and the posterior we calculated to be about normal of 0.514 and 0.094 for the sigma. And as same as the other model, we used posterior predictive checks for our analysis.